domestic design build mass timber company. As Mike mentioned, we are born out of Swinnerton Builders, which is a nationwide general contractor headquartered in the San Francisco Bay Area, but has offices across the country in 20 different locations. Timberlab was born out of the Swinnerton, Portland office and really got started working with Corey's team on the First Tech Federal Credit Union project. And we've grown significantly in the last 4 or 5 years, working to accelerate the mainstream adoption of mass timber in the US commercial construction market to benefit the planet and its people. We're a really service-oriented, mission-oriented company. We do a lot of industry engagement and education, and we are focused on helping all mass timber projects be successful, not just the ones that we get to participate in. So that's the future that we want to build. Just a little bit of history here for those of you who might be unfamiliar with us and Swinnerton. As I mentioned, Timberlab got its start on the First Tech Federal Credit Union project, which Swinnerton self-performed. And we had, as Corey mentioned, some big success on that project, delivering it for 4% cost savings compared to the steel structure that it was benchmarked against, and with a 4-month schedule savings as well. And we recognized that there was an opportunity in the market to deliver mass timber structures for commercial buildings. And so now we do about half of our business subcontracted to Swinnerton and the other half to other general contractors across the country. In the beginning of 2018, we launched Swinnerton Mass Timber, which was that subcontracting entity. And then over the last few years, we've been focused on addressing the bottlenecks and the pinch points in the mass timber market. We recognized fabrication level modeling as being a constraint and a huge, necessity, vital component to delivering these buildings. So we amped up our in-house virtual design and construction team to be able to take on the fabrication level modeling for these buildings. And we did the first fabrication level model for the Hidden Creek Community Center project. And then the next opportunity to help expand the mass timber supply chain and drive costs down was to open a fabrication facility. And we specifically focused on fabrication because we recognized an abundance of glulam manufacturing in the Pacific Northwest, companies that had been around since the 50s and 60s that were making high quality certified product, but weren't focused on the mass timber industry and didn't really have the sophistication or the technology to deliver custom building components. So they weren't taking their commodity product and, as Vito talked about, like transforming it into a custom building component. So we said, okay, let's try to complement the existing regional manufacturing capacity with a fabrication facility, and we opened that shop in just kind of a few months after the pandemic started, so in October of 2020. And we fabricated our first project for the Harder Mechanical headquarters in Portland. And then at the end of that year, we officially launched Timberlab as a separate business entity. Swinnerton and Timberlab have had the great privilege and pleasure of working on a number of mass timber projects. I think this isn't even all of them, but the ones that Timberlab and Swinnerton have worked on together. And we've worked in office and commercial buildings, civic buildings, higher education buildings, so many public projects. And then recently kind of embarking on this new market to deliver mid-rise and high-rise mass timber residential buildings as well. And what I think is interesting here is that public buildings are really a great fit for mass timber because public clients tend to have, they're not pro forma driven. And so they're committed to developing a building that has high community impact and in many cases, low environmental impact, right? And so mass timber checks both of those boxes. And we find that even when clients come to us not thinking about mass timber can meet many of the goals that they articulate to us during those first visioning sessions. So I think one of the things that's just absolutely critical to understand, and what Corey touched on, is just early team formation when delivering a mass timber project. And we show here in this graphic 2 different arcs of how one might deliver a project. To maximize benefits, we find it's really helpful to bring on a mass timber trade partner early in the design process, beginning in the schematic design phase. And that's because the majority of the cost driving decisions are made in schematic design. That's when we're thinking about grid layout and column spacing and construction type selection. And as the project gets more and more refined, there is less opportunity to influence the viability of a mass timber project and the overall cost competitiveness. So early engagement is critical. And all of this assumes here that a general contractor is on board, in the beginning, and that CMGC or design build delivery is a viable project delivery approach for the project. We've also worked on several design bid build projects, and they do not go as smoothly as when the whole team is able to work together from the beginning, and construction partners are able to provide feedback to the design team to help guide the project down a constructible, cost-effective path. So this early team formation is really different than what many people might be otherwise used to when delivering a concrete or steel, more conventional project, right? It requires either design assist or design build MEPF. So early commitments made to mechanical, electrical, plumbing, fire sprinkler trade partners, early commitments made to superstructure trade partners, and that's the mass timber, but also the lateral system, whoever's delivering the lateral system, so that might be a steel fabricator as well. And then the facade is an integral part of delivering this fully prefabricated system. And the reason this early team formation is essential is because, as Guido described, we're delivering an offsite prefabricated kit of parts and transforming the construction process into an assembly. That's the goal. And so decisions need to be made earlier, and financial commitments need to be made earlier in order to allow for that offsite prefabrication process to occur. And as much as possible, we try to do that prefabrication in parallel with the construction documents phase, or we do the kind of fabrication level modeling in parallel with the construction documents phase, and then follow shortly after with fabrication. But this requires just a much earlier decision-making timeline on many fronts. So I just wanted to put that out there for everyone, because we find it's really important to set those expectations early. So focusing specifically on the mass timber aspect of a project, let's just walk through the process. Design, I think we're all familiar with design, and we're working with an architect and an engineer to develop the mass timber structure, which has, as Corey mentioned, structure, fire protection, and finish functionality, right? And then we take those construction documents, 2D plans, and reconcile them into fabrication level information. And I use the word reconcile because this fabrication level design process is really a fourth phase of design, where we are taking construction documents to a whole nother level, trying to understand the geometry of a building to 16th inch precision. And that's not typically the precision that's in the plans at that stage of the project. So it's a big effort. It's a collaborative process, but it ultimately feeds into the fabrication process, because we can take that fabrication model and code it for a machine to be able to read, and then send it to our CNC machine, our robot cutting friend, who then custom cuts all of the glulam and CLT elements for the project into their precise geometry needed for the project. And then we take those custom cut pieces and attach steel hardware, connection hardware, wrap every component, ship it to site for installation or assembly. So let's kind of dissect that whole process a little bit. Design is not so straightforward. I think, you know, when we design a steel or concrete grid, we start with a 30 by 30 grid for a typical office building, for example, and that is just so not what we do for mass timber buildings. And in fact, there's so many different ways that one might organize a mass timber structure in any, you know, in one floor plan, or for a particular massing. And the 4 options that I show here for just one, you know, specific example building are 4 of you know, many that we looked at on this project. So an 18 by 25 foot grid on the left using double girders, and the double girder gives you a little bit of a shallower beam, so increases your ceiling height, okay? And then an 18 by 25 grid without the double girder, just a single girder. And then what about a 15 by 25 grid? Does that help at all? What about the 20 by 30 grid, reducing the number of interior columns, but now you've got beams running in 2 directions. And these are the studies that we're doing in schematic design, and it's, I think the reason why Corey mentioned that, one of the reasons why Corey mentions it's helpful to have a construction partner on board early is because having cost and constructability feedback on the direction that's taken with the grid is really helpful in making sure that the project is viable in the long run, and that meets all the, you know, architectural and programmatic and cost goals. So, okay, we looked at 4 options, but what about this one? So now we've taken all the beams that we saw running north-south in the previous slide, and we say, okay, what if we run them east-west, or left-right across the page? And now we've got no perimeter beam on the long sides of the building. We allow for increased daylight coming in, and maybe if we utilize this double girder system and the kind of primary beams and create a mechanical corridor along the middle of the building coming out of the building core, we have really integrated the mechanical system with the structure in a very elegant way that brings the duct up close to the ceiling, not running underneath a large deep beam. So I show you this because this kind of study is absolutely critical, and it takes time, and it's a collaborative effort, and it really is important to understand all the goals of the project. And in this case, the client was really concerned about ceiling height and the number of interior columns in their speculative office project. Okay, so one-way beam systems are worth exploring, and I kind of talked through that. And this is just an example of a one-way beam system. It's the First Tech Federal Credit Union project that Corey just showed. And these have really great benefits, but it's not the only system, right, that we shared. Some other examples of one-way beam systems and how they fit into a building massing. But when we're doing this kind of structural layout, as I showed in a couple, you know, as I just showed, we have to think about the mechanical system, and we have to think about how that ductwork, or how that air flows through the building. One way to do that is through a mechanical corridor, which can then easily branch out into the bays on potentially either side of the corridor, without the obstruction of any beam running along that corridor line. So that's a really nice clean solution. Raised access floor is another really great system worth exploring. And then building services integration is absolutely essential to delivering a high quality, clean, efficient mass timber building. In this case, you're looking at fire sprinklers running through glulam beams and organized in a really clean, elegant way. Same is true for the lighting that you can see in some of these images, all really very premeditated, pre-planned, and coordinated to allow for this uncluttered ceiling aesthetic. Okay, so now that we have kind of a design concept, we're taking that concept, or we call it design intent, and we start to really drill down into precise locations of building services, equipment, plumbing trees, electrical conduit, right? And also precise locations of the edge of that deck where the timber sits in relation to other structural elements like a concrete core or a steel brace frame. We're trying to understand the building to precise geometry so that we can custom cut all of the parts, this whole kit of parts, right? We call that virtual design and construction, but it's really translating the design intent into fabrication level information. This fourth phase of design, we try to do during the construction documents phase so that we're not adding on additional time during design. And we find that this works pretty well, although it's challenging if we're not ready to make some of these decisions, because typically the need for this information is a little bit ahead of where architects and engineers are in their own process. So there's conversation there, but I would say this is the lead time associated with the mass timber building. Like getting to fabrication level geometry takes time. It's weekly coordination meetings. It's work sessions, and it's ultimately what sets us up for success in the field, right? We're basically making our bed for when we get out to the site, lace up our boots, put on our tool belt. We want everything to be installed quickly, efficiently, safely, in a really high quality fashion. And it's this detailing virtual construction shop drawing process that enables that kind of outcome on the site. So you can see here, Lauren working at the computer. She's trying to understand exact location of all sorts of building services because we can prefabricate or pre-cut all of those holes in the timber factory so that an electrician or a plumber doesn't have to come in, survey the deck, and make the core in the field. And then she's drilling down to look at every single timber to timber component, figuring out how each piece fits together and modeling those components for fabrication, both the timber components and then the steel hardware as well. The coordination of building services, as I mentioned, is a huge team effort. This is the architect, the engineer, mechanical, electrical, plumbing, fire sprinkler, trade partners, timber trade partner, everyone working together to basically do construction. That's what we're doing. We're building the building. And it's happening in a virtual environment, but that doesn't mean it's any less important that we get it right. And in the past, you know, people are familiar with BIM coordination. That's BIM for, you know, clash detection to make sure that in the field we don't have any issues, but it didn't really have much consequence. Whereas here, this BIM model, building information model, is being used for fabrication. And so it's absolutely imperative that every piece is in the right location, modeled in the right sizing, and that it all like meets both architectural intent as well as kind of constructability goals. So I think this is a really, you know, often not well understood process, and it's what sets mass timber apart in many ways. Okay, I did want to spend some time I told everybody that I didn't have too many slides, but apparently I have too many slides. I did want to spend some time talking about what's happening in parallel while we're designing this fabrication level model. And I've seen in the chat a lot of talk about, or questions about, where the wood is coming from. And I think as you read the chat, it almost appears a little bit antagonistic, and I think very defensive. And I think the reason we're seeing that,
hey Erica,
is because, yeah.
Do you want to switch to Daniel so you can get some water and kind of see if you're doing okay? I don't want to rush through your program if you need a minute. So
Thanks so much. I think I'm okay.
Okay.
I think the reason why we care so much about where the wood is coming from is because our lives are so intrinsically connected to trees. It was our first shelter, our first tool. Our use of wood for fire is what made it possible for us, our brains, to grow to the point where, so that we could eat nourishing food and, make our brains grow to the point where we could have this conversation today. It makes sense. And actually, I think it's incredible that this symposium is sparking conversations about where materials come from, and hopefully we have those conversations not just when we're talking about mass timber, but when we're talking about concrete and steel as well. We should be asking about where the sand in our concrete is coming from, and I don't know how often that's happening. So I think it's great dialogue, and forestry, silviculture is a constantly evolving science. I have lots of opportunity for improvement. In the Pacific Northwest, there are Forest Practices Acts that govern how lands are managed, and then of course it's up to individual companies to manage to even higher standards. In the United States and here in Oregon and Washington, the majority of timber is coming from privately owned lands, and those could be managed by small family landowners or large industrial companies like Weyerhaeuser. And the forest management practices vary, right? And we have lots of opportunity here to specify the kind of wood that we want to use in our buildings. And the mechanisms may not yet exist to track wood all the way back to the forest of origin, although we're doing that on a couple of projects at significant scale, but it takes a lot of work, a lot of conversation, communication, and I think if it's something that we care about, we can continue to make it happen. We have technology. I mean, who knows, we might figure out a blockchain solution to tracing trees from the forest into our buildings. So I think it's great to have these conversations. Trees are then harvested. They're brought to a sawmill. They're piled high on a log deck. They're run through a sawmill. You can see them being planed into lumber. They're stacked into dimensional, stacked into lifts of lumber, sent to a CLT or glue lam manufacturing facility, pressed into, in this case, looks like 5-ply CLT panels, glue lam beams glued up into their dimensions needed for the project. All of this material, by the way, is manufactured in a press and then fabricated on a CNC machine. And then that prefabrication process that I described is that next step where we're assembling components into a greater level of a value add element for a project. And then lastly, delivering all those materials to a building and lifting them into place, erecting them in their intended location, and fastening them together with typically wood screws, maybe some through bolts, but it's a Lego kit at that point. It's a Lincoln Logs. It's a kit of parts assembly that requires safe handling, but all of the hard work has been done by this point to make sure that this structure fits together safely and efficiently. So that's what that installation looks like. And then if you're really, thoughtful about construction, you're erecting your facade just 2 stories behind the timber structure, and you're advancing follow-on trade work quickly behind the timber, 1 floor or 2 floors below the timber structure as it's being erected. So when we think about construction schedules and the efficiency opportunity there, it's not just with the timber structure, it's with all the follow-on trades as well. And the reason we were able to achieve the 4-month schedule savings on the first tech project, and why we were able to see that on subsequent projects, is because we're looking at early move-in of follow-on trades. And so the overall schedule is compressed significantly, and up to 20% in many cases. And then we arrive at a completed building. So hopefully I've given you a sense of what that process looks like. I apologize for the coughing fit, and glad to take any questions at the appropriate time. So thanks for your attention.
Thank you so much, Erica. Let's do, I think, a couple of questions. We'll hit on some of those things, especially the sourcing, the LCA. I think it's an issue that we could talk about for days in the Q&A process. Next up, we have Daniel Hall.